trigonometric functions. So the inverse sine function is defined on this interval from negative pi over 2 to pi over 2. And this is a graphic of showing that. So inverse sine function will only be defined in quadrant 1 and quadrant 4. That's just to ensure that this is actually a function so that you don't get two outputs for the same input. All right. And cosine is going to be defined from 0 to pi. Inverse cosine, will be defined between 0 and positive pi. Same reasoning, because we don't want there to be two outputs for the same input. Here's a graphic of what that would look like. That would be quadrant 1 or 2, the upper half of the unit circle. Tangent is defined between negative pi over 2 and positive pi over 2. And that's going to be similar to inverse sine, will be defined on quadrant 1 and quadrant 4, so between negative pi over 2 and positive pi over 2. So let's do some examples. So the inverse sine of a half, so we can use our unit circle. So we're looking for the angle that has a sine value of a half. So if you go to your unit circle, inverse sine is only defined in quadrant 1 or quadrant 4. So if you look at the y-coordinates, that sine of a half, that would be this angle, which is pi over 6. So for A, this would be pi over 6. All right, we're looking for the arc cosine is another way to say cosine inverse. That's the same, just different notation for the same problem. So we're looking for the x-coordinate of negative radical 3 over 2. Inverse cosine is defined on these two quadrants, so that would be this one, x-coordinate of negative radical 3 over 2, which is 5, 6 pi. Inverse tangent of negative 1, that would be in quadrant 1 or 4. Because it's negative, it would have to be quadrant 4. Y divided by x would be this angle here, which is 7/4 pi. All right, for these problems, we just need to use our calculator. So let's try a few of these. So for the first one, inverse sine of 0.5075 would be, and they want us to be in degree mode, as you can see. So change your calculators to degree mode if it's not already in it. Inverse sine of 0.5075 is 30.5 degrees. And you need to make sure that the angle is in quadrant 1 or quadrant 4, which it is. Second one, same problem, just negative this time. And that is negative 30.5. That is also in quadrant 4, which is good. The next problem would be inverse cos. 0.6428. That would be 49.9. So we can round that up to 50 degrees. That should be in quadrant 1, which it is, or quadrant 2. And let's try this next one. Inverse cosine of negative 0.6428. That would be 130 degrees. And that is good because this is in quadrant 2, which means it's okay. Inverse tangent, 4.474. That's going to be 77 degrees, 77.4 degrees. And the last one is inverse tan of negative 4.474. And that is going to be negative 77 degrees. 0.4. All right. And for this one here, whenever you have a kind of two functions going on, what you want to do is first focus on this. We're looking for the angle that has a sine coordinate of 1/2. So if you look at your unit circles, y coordinate of a half would be pi over 6. So that would be sine of pi over 6. And now we know that that is 1/2. All right, the next one. First, we want to work from the inside. We want to work from the inside out. So the sine of 135 degrees, that would be 135 is right here. So the sine is radical 2 over 2. So now we're looking for the inverse sine, or the angle that has a sine value of radical 2 over 2. So going back to your unit circles, you got to be in one of these two quadrants. So we're looking for radical 2 over 2. So that would be this one. And it's got to be pi over 4, which is 45 degrees. Okay. For this problem, we want to work from the inside out as well. We can change this to be a ratio, x over 1. So let's draw this right triangle. And quadrant, they should say, okay, so in x only. So let's draw this in the first quadrant. So this would be our theta, we'll call it theta. And this would be adjacent over hypotenuse. So adjacent over hypotenuse. If you do the Pythagorean theorem, you're going to get 1 minus x squared, the square root of that. So I just did this, the Pythagorean theorem. A squared plus b squared is equal to c squared. And now we want the sine of the angle. I'm calling the angle theta. So the sine would be opposite over hypotenuse. So our final answer would be opposite over hypotenuse over 1, which you don't have to write the over 1 part. So this would be our final answer. All right, let's look at the homework. We'll start with number 3. So we're looking for the angle whose sine coordinate is radical 3 over 2. Radical 3 over 2 would be this one, so pi over 3 or 60 degrees, whichever they're asking for. In this case, they're asking for a radian, so pi over 3 it is. For the next one, the inverse cosine of negative 1, so you go and you look for negative 1. Cosine would be this one, so the angle would be pi or 180. So in this case, we want pi. All right, so for this inverse sine of a half, same thing, go to your unit circles. Inverse 1/2 would be right here. Sine would be this or this. Pi over 6, pi over 6 it is. Arctan, which is tan inverse of radical 3, that would be, it's either going to be this number divided by this number or this number divided by this number. We already know that this is tangent of these is 1 because y divided by x is 1. Turns out it's going to be this one. When you divide this number by this number, you end up with radical 3, so it's going to be pi over 3. Arcsine of radical 3 over 2. So remember, inverse sine is defined here or here. Since it's negative, it's going to be down here. And sine is a y-coordinate, so it has to be 5/3 pi. Whoops, sorry about that. 5/3 pi, however, is not in the interval. So what you need to do in this situation, since we said it was 5/3 pi, this is the correct answer, however, but since we're not, the interval must be between negative pi over 2 and positive pi over 2. So we wouldn't call it 5/3 pi, we would call it negative pi over 3. This is positive pi over 3. We're going negative pi over 3. That was my fault. All right, for the next one, so we're looking for the tangent value that has this tangent value. So that would be quadrant 4 because this is where it's negative. This is where it's positive. So if you divide this number by this number, you will get radical 3 over 3. So it will be 11/6 pi. But however, we don't call it 11/6 pi. We call it pi over 6, but in the negative direction, so negative pi over 6. For this one, we need to use our calculator. So if you do our inverse cosine of 0.8411, you should get 32.7 degrees. And if you do the arctan or inverse tan of negative 0.2834, you should get negative 15.8. For this one, you work from the inside out. So sine of 210 would be negative 1/2. And then we're looking for the angle that has a y-coordinate of negative 1/2. So that would be right here. And this would be the angle, but we don't call it 11/6, we call it negative pi over 6. So negative pi over 6, which is another way to say 30 degrees. Pi over 6 is the same as 30. So yeah, it should be 30 degrees because they're asking for degrees, I believe. Yeah, see the degrees. So my bad, negative 30. All right, for this one, since 7/8, what we can do for that is we want to draw a triangle in quadrant number 1. We'll call it theta again. And this is adjacent over hypotenuse, so that would be 7/8. Since they're only asking for cosine, we don't really need to find this. If they would have been asking for sine, we would have needed opposite over hypotenuse, or tangent would have been opposite adjacent. But since they're asking for cosine, they're just asking for 7/8. So that is our answer, 7/8, because the cosine of the angle is adjacent over hypotenuse, which is 7/8. This one, same idea. Draw a triangle, quadrant 1. So that's opposite over hypotenuse. In this case, you would need to find the missing leg because they're asking for tangent, which is opposite adjacent. So this is going to be, if you do the Pythagorean theorem, a 3, 4, 5 triangle, 3, 4, 5. And so the tangent of the angle, I'm calling it theta again, would be opposite over adjacent, 4/3.